In the last video, we worked on this example, and we found that we had these vertices. Remember, vertices are the points that all of them intersect. So we found we have a vertex at that point, a vertex at this point, and a vertex at this point. It's a point whenever all the lines intersect each other. So the boundaries tell us where it has to be within. So with this example here, we have that it has to be between or within this boundary. Okay, so the only spot where our solutions were is inside of that little triangle. For our last example, we have find the coordinates of the vertices, of the triangles formed by y less than or equal to 2x plus 2, y is greater than x minus by 1, and y is greater than or equal to negative 2x plus 8. Just to let you know, this should have an equal to underneath it as well. Whenever that was written down, they forgot to put that equal to sign there. So let's go ahead and just write this out. We have a system of inequalities. We have y is less than or equal to 2x plus 2. We have y is greater than or equal to x minus 1. And we have y is greater than or equal to negative 2x plus 8. Graph each of them. Whenever we're doing this, we just want to graph each of these. So 2x plus 2, that's easy. We're going to put our y-intercept at 2. We rise by 2, run by 2. So that's going to be, not rise by 2, run by 2. Rise by 2, run by 1. I'll get there eventually. Rise by 2, run by 1. So our graph of this one is just going to go through these points. The next question is, which side do we shade? Well, let's just choose one of the points, a random point. We can choose 0, 0. Any point that's not on this graph will work. So let's try 0, 0. 0, 0 is always a good option. If we try 0, 0, this would be 0 is less than or equal to 0 plus 2. That is true. So because 0, 0 is a good option, we're going to shade underneath. So this would be solution set to just that one inequality. Let's go ahead and graph our next inequality on this line as well, on this coordinate plane. If we have y is bigger than or equal to x minus by 1, we are going to have a y-intercept being at negative 1. And we're going to have a slope being positive 1, up 1, over 1, up 1, over 1. And I'm going to use a different color than purple. We're going to go up 1, over 1. And so on. We're just going to connect these dots. The disadvantage to graphing, if your graph is off, you may end up with the wrong number. But we are going to do it in an algebraic way as well. Choose a point. We know 0, 0 is not on that, so this would be 0 is bigger than or equal to negative 1. That is true. So we shade towards 0, 0 for this one, which is going to be up this way. So let's go ahead and just shade all of that. Remember, it's only a solution to this whole system of inequality if it is shaded in all three regions. So far, the only shaded region is between the pink and the purple. Let's go ahead and graph this last one. We're at positive 8 as our intercept. We're going to go down 2 over 1, down 2 over 1, down 2 over 1, and so on. So we are going to have our graph look something along this lines. Pick a point. 0, 0 is not on the graph. That's always the best point. You can choose any other point. It does not matter. But I'm going to choose 0, 0. So we have 0 is bigger than or equal to 8. That is not true. So we need a shade away from 0, 0 in this case. So we are going to shade away from 0, 0 would be this way. And I think whenever they made this equation, they actually meant it to go the other direction. So we are going to just fix a few things with this. So we have y is bigger than that. What I'm going to end up doing for the sake of this question because I want us to find the vertices of this, I want to change just one thing. We're going to change this to be a less than or equal instead of then a bigger than or equal. So let's change that inequality just so that it works within our triangle. So we're going to change that so that this would be actually shaded towards 0, 0. So let's shade this direction. We'll get there eventually. So we're going to shade towards the 0, 0 since we changed the inequality. So this would be where our region is. And lastly, the only spot where all three overlap is in this triangle, which is what they're wanting. They want us to find the vertices of the triangle. So let me just find out where they intersect. We have an intersecting point right here, intersecting point up here, and intersecting point down here. These are my blue dots. So we have the boundary, which is gonna connect those blue dots, the blue points, the blue vertices. Okay, so we need to find out where they intersect. Well, one way we can do this is we can look at the graph. However, if we graph this wrong, then we may end up with some wrong solutions. I'm going to show you how to do this in an algebraic way. What we're going to do is we're going to take two of the inequalities and set them equal to each other. We're going to use our substitution method whenever we're solving systems of equations. So let's just pick these two real quick and set them equal. Both of them have y. So let's find the x value that would make them the same. So we have 2x plus 2 equals to x minus by 1. And we're just going to use equals for now just to make it more simple. Solve for x, so we minus by x on both sides and minus by 2 on both sides. So x is equal to negative 3, right? That's this point right down here that we're looking at. If x is negative 3, plug it into one of those. What is our y value? If x is negative 3, let's just choose this one here. Then this would be y equals to negative 3 minus by 1, which gives us negative 4. So one vertice is at negative 3, negative 4. Okay, well, it looks like our graph so far is accurate. Those two lines cross at negative 3, negative 4. We checked that. That works with both of those inequalities. Okay, well, let's grab another set of two. Let's grab this first one and this last one. Let's figure out what vertice that would give us. They're both equal to y, or set with y by itself, so let's just set them equal to each other. 2x plus 2 equals to negative 2x plus 8. Plus 8. Solve for x. So we are going to add 2 to both sides. So this would be 4x. Sorry, add 2x to both sides. So we end up with 4x plus 2 equals to 8. Minus by 2, so 4x equals to 6. Divide by 4, so x is equal to 6 over 4, or in other words, 3 over 2. So this one we're looking at 1.5. We're looking at this point up here. This is a point that we're looking at right now. Okay. Well, what is the y value for that? If x is 3 over 2, let's just substitute that into one of the equations or one of the inequalities. Let's choose doing this top one. So this would be y. Let's just set it equal to 2 times 3 over 2 plus 2, which gives us that y is equal to 3 plus 2, which gives us 5. So our next vertice is at 3 over 2, comma 5. Well, is that accurate? Yeah, that point is at 1.5, comma 5. So far our graph seems to check out. It seems to be that we graphed it accurately. For the last pair of points, let's just do the same thing we've been doing. Let's choose 2 more. So we did, just really quick, we did the top 2 together. We did the top and the bottom. Now let's do the bottom 2 together. Okay, just to make sure we do variations of each one. So we're now going to do the bottom 2 equations. And just for the sake of space, I'm going to erase a few things so that I can write the new equation. So the bottom 2, we have x minus by 1 equals to negative 2x plus 8. Solving out for x, we add 2x to both sides. So this is 3x minus by 1 equals to 8. Add 1, so 3x equals to 9. Divide by 3, so x is equal to 3. By the way, our x is at 3. Let's just find our y. Plug it into one of the bottom two. We will end up with y equals to 3 minus by 1, which gives us 2, which is indeed where that vertex is. Okay? So if you want to find the vertices, start with picking two of the inequalities, set them equal. Solve for x, plug it into one of the two, you have your y. You have your x and y value. Pick the next set of two. Make sure it's not the same two. Set them equal. Then find the x value, substitute it into one of those two equations, solve for y. You have your next vertice, and so on and so forth. You just have to set the two inequalities equal to each other, solve for x, and then substitute to solve for the y value. And that is how you find the vertices of a system of linear inequality.